Now, the first type of number is a prime number. And a prime number, as we all know, is a number which has only two factors, 1 and itself. So, and on the right side here now, we've given you a list of all the prime numbers. And like starting off with 2, and remember 2 is the first prime number. And apparently 2 is the only even number which is prime. And the second number is 3 there again, only two factors, 1 and 3. 5, again the factors 1 and 5. 7, 1 and 7, and so on. So all the list is given here for you to memorize and make sure that you do not get these wrong. And then again you have at the bottom, you have prime numbers to 100, right? All shown in blue here, like 2, 3, 7, 11, 13, 17, and 19. Now let's recap everything that I've said here. And so a prime number has only two factors, 1 and itself, can only be divided by 1 and itself, and the first prime number is 2. And lots of people make mistakes with this. 1 is not a prime number because 1 has only one factor. So the first prime number is 2, and 2 is the only even number that is prime. And then you have a list of all the prime numbers at the bottom as 2, 3, 5, 7, 11, 13, 17, 19, 23. And you should learn this by heart so you don't have any problems with these questions. The next one is square numbers. And the square number is a number which when multiplied by itself. For example, 1 times 1 gives you 1. 2 times 2 gives you 4. 3 times 3 gives you 9. So all these 1, 4, 9 are square numbers. And we've given you all the square numbers till 100 here. So a square of a number is a number multiplied by itself. Like 6 times 6 is 36. And as you can see here, we've shown 36 as 6 to the power 2. And the 2 indicates such a square number. And again here 4 to the power 2. The square of 4 is 16. And the square of 5 is 25. The square of 6 is 36. And all perfect squares are squares of whole numbers. And the square root of a number n is a number that gives n when multiplied by itself. An example here, 36. The square root of 36 is 6 because 6 times 6 is 36. Now, we've shown you at the bottom here the sign for square root. So the opposite of a square is the square root, right? So if you take, for example, here 25, the square root of 25 is 5. Similarly, the square root of 81 is 92. So recapping this, the square of a number is a number multiplied by itself. 6 is square of 6 is 6 times 6. And perfect squares are squares of whole numbers. And square root of 36 is 6 times 6 is 6 because 6 times 6 is 36. And the sign for square root is this sign shown here. Now, next number is a cube number. And a cube number is a number which forms, for example, 2 times 2. When a number is multiplied twice by itself, like 2 times 2 times 2 gives you here 2 times 2, 4, 8. And so 8 is a cube number. And you can write this with a 3 at the top here as an index. So 2 to the power 3 is 2 cubed. And at the bottom here, we are given all the cube numbers. So the cube of 1 is 1, cube of 2 is 8, and a cube of 3 is 27, and so on. And for comparison here now, I've actually put the square numbers to the top. So you see the square numbers, all the square numbers at the top here, 1, 4, 9, 16. And at the bottom, you have the cube numbers. So a square of 1, this is square of 2, which is 4, square of 3, and a cube of 1, and a cube of 2, and a cube of 3. So the square numbers at the top and cube numbers at the bottom. Now let's recap all this that we have learned. So the cube of a number is a number multiplied by itself twice. Now, the cube of 4 is 4 times 4 times 4 is 64. And see the chart for examples here. So these are all your examples. So please, I would suggest you memorize some of these numbers, at least till 216. First 1, 2, 3, 4, 5, 6. 6th cube number 216. So, I mean, those square numbers are fairly easy, but the cube numbers, at least memorize the first 4 or 5 cube numbers. And on the right, we've also been shown that what a cube looks like is 2 times 2 times 2. Now, let's look at triangular numbers. Now, triangular numbers are numbers, as you can see here. And this is a list of the triangle numbers 1, 3, 6, 10, 15, 21, and so on. So, and it's simply the number of dots in each triangular pattern. So you have the first triangle number with 1 dot, the second triangle numbers with, as you can see, 3 dots, third triangle numbers with 6 dots, and then 4 dots, 10 dots for fourth triangle number, and the fifth triangle number is 15 dots. Now we show you how we derive this. So the first triangle number is 1 dot, and the second triangle number, here second triangle has another row, and it makes 1 plus 2, which is 3. Now everything will fall into place eventually when you see exactly how the sequence works. And the third triangle number has another row with 3 extra dots, making 1 plus 2 plus 3. And as you can see here, it's a summation of numbers, like 1 plus 2 is 3, and 1 plus 2 plus 3 is 6. And then you can see 1 plus 2 plus 3 plus 4 is 10. Now, do you understand the sequence here? Now, if you see you want to find the next one, the fifth triangle numbers, you would add 5 to the 10. And then similarly, you would add 6 and 7 and 8 and so on. Now, let's look at the formula here. And really, you don't need this formula, especially for your exams. But I've just put it on as finding the nth term. So if you take up a number from here, let's take 1, 2, 3, right, third and fourth. And the fourth number here is fourth triangle number is 10. So all you simply have to do is substitute n for 4. So if you put 4 for n here, and I'm going to write on it, so I'm going to put 4 for n here and 4 for n there. So as you can see, you solve the bracket first. 5 times 4 is 20, and divide by 2 is 10. And you get your 4 triangle numbers. Similarly, if you want to find fifth triangle numbers, put n as 5, and sixth triangle number, put n as 6. So it is quite a good rule, and if you can remember it, it'll be very good. Otherwise, it's a summation of numbers, and the triangles actually show you what how the dots are formed, and so that is also easy. So we've got all these triangle numbers, and then we're looking at something called BODMAS, which I'm sure you are fairly aware of it, but let's have a look at it. And BODMAS. Now, what is BODMAS, by the way? BODMAS is simply showing you the order of operations. So if you look at here, brackets first is telling you that you've got to solve brackets first. If you look at the question, see if you have brackets, solve the brackets first. Now, the order is something most people don't understand. Is order is like square numbers, like square or any number which has got a power, and the opposite of that is the square root. So the order is the second operation that you must do. And as you can see, I have put actually, there's a divide and multiplication, but I've put OR. And the reason for that is, I mean, it doesn't make any difference whether when you have those two divide and multiplication operations, then whether you do multiplication or division first, the answer is the same. So it doesn't really matter what you do, whether you divide or multiply in most cases, right? Then the last thing you would do here is to add and subtract. So remember, the last thing in any operation is addition and subtraction. So that's the last. Now we will take up on the left side, as you see, we've put some question there for you, but we'll attempt that question later on. And the first, we have to handle this question on the right hand side and see if you understand how we operate this BODMAS. So remember, BODMAS is nothing but the order. It indicates the order of your operations. Now, if you look at your question number 1, and you can see the multiplication sign, but you got a bracket sign. And if you go back to the top here, brackets, so you solve the brackets first. And I'll solve these brackets first, which is, as you see, 4 plus 5, which is 9. So when you solve the bracket 9, then you multiply by 10, and so the answer will be 90 here. I don't want to put 8, but the answer is 90 here, as you can see. And I might as well put it there. Right, so this first answer is 90. Right, now we go on to second question again. As you can see, there's a plus sign there, the brackets, there's minus and multiply, but minus again is within the bracket. So what we'll do is we will solve the brackets first. So if you solve the brackets first, you can see 5 minus 3. That's the first thing to do, is 2 here, and then 6 times 2 is 12. And then you can do addition as a last thing. So this part here is 2, and that is 12. So you can add now simply 2 plus 12, and the answer will be 14 there. Right, now if you look at this third question here, now this is what we call the order now, as you can see. But again, it doesn't make much difference in this particular case. You got multiplication there as well. But as you know, this is 5 squared is 5 times 5, which is 25 times 3. And the answer is 75 there. So, and question number 4, and this is a beautiful question for simpler reason that now most students make mistakes here. And when you see a question like this, and there's no order, they basically just carry on. They'll subtract the 1, they get 4, and then they multiply by 3 and get answer 12, which is totally wrong. And if you look back again to the BODMAS here, it says addition and subtraction is the last thing you do. So in this particular case, what you would do is you multiply the 1 and 3, which is give you 3, and 5 take with 3 is 2. So that answer is 2. And I will go through this again for those of you who don't understand it, is that we don't subtract first, we multiply first. So multiply the 1 and 3 and then do your subtraction. So answer is 2. And your question number 5 is, as again, beautiful question here. Now this is okay because the reason is, even if you don't understand it, obviously you're going to divide first, move this way, and then add 5. But really speaking, you've got to understand this, that what you need to do is, division first and then addition. So 12 divided by 6 is 2, and then you plus your 5, and the answer is 7. And so that is question number 5. Your question number 6 here. Now, as I said to you, I have shown you, indicated here, that or, and the reason I put or here is for the simple reason that you can divide or multiply. It doesn't make any difference, whatever you want to do. And because you in this question number 6, you have divide and multiply, it doesn't matter what you do, just divide. 40 divided by 4 is 10 times 5, and your answer is 50. So you got 50 there. Right, and this next question we have is question number 7, and again, beautiful question, because right at the beginning you have your subtraction sign, and you know that you cannot do it. You need to conform to the BODMAS operation, order of operation, and number 7, so you would really divide. There's a divide sign there, so you divide your 10 by 5 and you get a 2. So what you're going to do is 20 take away 2 is 18, and the answer is 18 here. And I should go through this again over and over again and try to understand this. And then the last question on this is, do the brackets first, and within those brackets again you've got order, which is 3 squared, and 3 squared is 9, and 9 times 4 is 36 plus 6, and your answer will be 42. Right, I was waiting to show you this question here on the left side. So 2 students, and again I think before I start that, again you got this indication of what these signs or letters mean here, which you are or should be aware of. And the 2 students, Sally and Mary, were given the same question, and both of the students came up with different answers. Which one of the students used the order of operations and had the correct answer? Now, as you can see, what Sally did was she just added the 2 and 5 and 7, and she multiplied 4. And that's the reason she got 28. So she hasn't followed any operation rules. She's just carried on and just added first. which you know is totally wrong. Whereas Mary is the intelligent one here, and she's quite aware of the BODMAS and the operation order operation. So what she's done is she's not added first. She's multiplied 5 and 4, and that's 20, and then she's added the 2. The answer is 22. So we know now that our friend Mary is correct, and the answer is 22. Interestingly, this exercise is quite interesting, and so obviously that's BODMAS, but if you have any more questions, then we can sort those out. So that's BODMAS. Now, tests of divisibility. This is again a very important section. And tests of divisibility, let's look at all the tests. First of all, try to explain to you what divisible means and what divisibility means. And divisible by means when you divide one number by another, the result is a whole number. And you know what a whole number is, no remainder. So examples we're given here is that 14 is divisible by 7. Why do we say that? Because when you divide 14 by 7, you get 2. Exactly. There's no remainder. So that number is divisible. But whereas if you have the 15 is not divisible by 7, because if you divide by 7, yes, it goes in, 7 goes twice, but you're left with 1 remainder here. So therefore, the result is not a whole number. So we would say that is 15 is not divisible by 7. And 0, by the way, for those of you who don't know, is regarded as a whole number. And 0 is divisible by 7 because 0 divided by 7 is 0. So divisible by and can be exactly divided by means the same thing. That's important to understand. Now, before we look at all the rules for the numbers for divisibility test, let's look at this simple example. And this rules let you test if one number is divisible by another without having to do too much caution. But an example which you have taken is 723. Now let me see if I can write this down. So your example here is 723. Now this 723 we are trying to divide by 3, and our rule says you find add these are called digits. Now the 3 digits here, 7, 2 and 3, and add the digits. In other words, I mean, some people say find the sum of the digits, which is the same thing, add the digits or find the sum of the digits. And as you know, your 7 plus your 2 plus your 3 gives you 12. Now, is 12 divisible by 3? Does 12 come in your 3 times table? Yes, it does. So this number 723 can be divided by 3 or is divisible by 3. So that's a good example. Now let's look at all these numbers individually. And the first number is, we said, any integer. Now, by the way, for those of you who don't know, integer is not a fraction, and so is divisible by 1. 1 is divisible by 1. If you look at the tests of divisibility for 2, and all we're saying to you here is that look at the last digit, and the last digit should be even. And if for those of you who don't understand, even numbers are numbers like numbers which come in 2 times table, like 0, 2, 4, 6 and 8. Those are even digits, and I would say digits here. Okay, now so you have a number, first number is 1 to 8, and the last digit is 8, which comes in a 2 times table. So yes, it can be divided by 2. But the second example which you put forward, and the last digit is 9, and this particular case 9 cannot be divided by 2 exactly, and does not come in 2 times table. So we say no. So that is fairly easy. Now the first example we showed you was based on 3, and again we come back to test of divisibility for 3 here. So the first example we put forward is 381, and so 381, and let me get the pen back. So 3, 8 and 1, 3 digits. If you add the 3 digits, 3 plus 8 plus 1, right, and that gives you 12. And really 12 can be divided by 3, or it comes in your 3 times table. So we would say yes to this number, right? Whereas if you have the next one, which is 217, and therefore if you add these 2 plus 1 plus 7, and it gives you a total of 10. And really 10 cannot be divided by 3, does not come in the 3 times table. So for this number we'll have to say no. It failed the divisibility 3 test, and the first one passed it. So that's for 3. Now let's look at 4. And the 4 test of divisibility is that you look at the number form by the last 2 digits. So if you look at 1, 3, 1, 2, and the number form by the last 2 digit is 12, and 12 you can divide by 4. So yes, so we'll say yes to this number. And if you look at the second number, which is 0, 1, 9, and the number formed by the last 2 digits is 19. And 19, if you attempt to divide it by 4, right, gives you 4, and there's a remainder of 3. So this number is not divisible by 4. So I'm going to say no, I'm going to reject it. And those are the tests for 4. Now, really, the 5 tests are very simple, because all you've got to look at is the last digit. And if the last digit is 0 or 5, then it's passed the divisibility test. So that's straightforward. Now we're going to look at something like 6, for example. And 6, again, a very easy test. And the test says that, look at the rule for 2 and look at the rule for 3. So the test for divisibility by 3 is that it passes both 2 rule and the 3 rule. And we're quite aware of the 2 rule now. 2 rule is that the last digit should be even, and the 3 rule says that you just add and see if add the digits and see if the number comes in your 3 times table. So that's the test for 6, which is straightforward. But I will take the first part here, or the second question here, like for example 308. Now that's 308 definitely passes the 2 test. Does it pass the 3 test? And the 3 test, you add 3 and 11, which gives you 3 and 8, which gives you 11. So it definitely does not pass the 3 test. So it fails the 6 test then, because it's passed the 2 test, but it's failed the 3 test. So it fails the 6 test. Now 7 is one of the most important numbers here for divisibility. And so what with 7 we do is, so if you look at 672 now, and we're testing for 7, and so look at the instructions now. Double the last digit and subtract it. So it says double the last digit and subtract it from a number made by the other digits, and the result must be divisible by 7. So if you look at now this number 672, so you double the 2, which is 4, and then you subtract it by the number formed by the first 2 digits here, and it gives you an answer of 63. And you know 63 comes in your 7 times table. So I hope you have to go through this again, right, to understand it. Now I give you, if you look at another one, that's 105, for example. So what did we say? Double the last digit, which gives you 10, and the number formed by the first 2 digits is 10. And 10 take away 10 is 0, and 0 can be divided by 7. So yes, it can. And the third example, which is here, is that you've got the number 9 or 5. So you double the 5, which gives you a 10, subtract it from the number formed by the first 2 digits, and you get 80. And definitely 80 does not come in a 7 times table. So I would have to say no to 905. Now the test for 8 is similar to test for 4, but here what you have to do is to divide by, look at the number formed by the last 3 digits, 816. Now 816, if you divide by 8, you get 102. So yes, the answer, I would say yes to that. And the second part again, here I would say no to this, because 302 cannot be divided by 8. Now as a quick check, now you know 8, by the way, 8, as you know, is 2 times 2 times 2. Now if you understand the factors here of 8, then all you can simply do, if you have a number and you want to test for 8, you can also half it once, half it twice, and half it 3 times. So for example, you had that number there, 816, half it, then half it again, and half the answer again, and so on. So if you have like the 816, you half it, you get 408. Then you half it again, you get 204. Then you half 204, you get 102. All right, now, and so you can carry on like this, and so, so straightforward. But I suggest most of these questions that you get are fairly easy. So that's the test for 8. Now let's look at test for 9. And the test for 9 is again similar to test for 3, because you've got to find, I say sum, and you know what sum means. Add all the digits, and if you get an answer which can be divided by 9, then yes, you can do it. And the next one again. And by the way, you can repeat this rule. By the way, you can repeat it. Let me show you. I've got a number here. Let me go back to this. I've got a number here, 1629. So if you add 1 plus 6 plus 2 plus 9, it gives me 18. Now, this is just to make you understand. Now, you know 18, you have to say yes based on that. But if the number is too big, then you can apply the same rule again. So that 18, I'm not sure whether, let's presume that I don't know that it comes in your 9 times table. So what I'm going to do then is, I'm going to add the 1 and 8 again, and I get 9. So definitely 9, I'm sure, comes in a 9 times table. So I would say yes to this number. So the whole idea is that with these very big and long numbers, you can apply this rule once, twice, 3, 4 times, as many times as you like, and it can be repeated till you get a number which you're familiar with and which you understand. And question number 10 is simply looking for 0 at the end. All right, the divisibility test for 10 is look for 0 at the end. And this is a really good exercise, right? And this is the end of your video now. And this was an interesting explanation, and I hope you will enjoy it. Thank you.